welcome to open our Google Slides for the week. And Mr. Blake is going to lead us in a little bit of a discussion about our thoughts as we are moving toward returning to school. Woohoo! Is one of my many responses. Review and reflect on 225 Desmos activity, our Desmos activity from last Thursday. Hi, Funstock. Thanks so much. There are 3 points I want to make sure we get out of it. We'll talk about those in a little while. And then there's a real short Desmos ALEKS activity or ALEKS assignment that we're going to do today. So that's what's going on. I'm about to hand things over to the amazing Mr. Blake as soon as I put up this really cool slide that he created. There we go, Mr. Blake.
Hey, everybody. I hope your day's been good. So I really just want to ask you all, when you think about coming back to school, which one of these GIFs or GIFs represent you the best? Which one do you feel like? And so if you can go to this Jamboard right here, Malcolm, if you could stop for a second, just so that people can get the link. And then, so join that Jamboard and type in, add a little sticky note or text box to the Jamboard and type in which GIF represents you the best, how you feel about returning to school, and then write a little description about why, answering those questions about how you feel going back to school in person and what thoughts you have about that. Yeah. And for me, I am probably a mixture between them, a little bit of 1, a little bit of 2, a little bit of 8, because 2 was the first one because I'm like, what? I had no idea we were about to go back, so I was kind of surprised. But 1, because I'm looking forward to it and I can't wait to meet you all and yeah, and be at school. But then 8 because it's kind of nerve-wracking, right? I've never been to Mifflin before, so it's a little nerve-wracking, but yeah, so that's how I'm feeling. I would love, and we're starting to get some answers on the Jamboard, which is great. A little nervous. 6 because I like staying at home. I understand that. It'll be fine. I'm nervous and shy. Active being invisible as usual. Get out of the house. Well, whoever is writing these things, we cannot wait to meet all of you and to see all of you and get to know you all. Keep the answers coming. I'm loving this. This is great. Mr. Reed, do you want to share what you're feeling, which numbers you're feeling the most?
I say that had to have been that one dude named Malcolm that's consuming the entire board right now. Surely is that Malcolm?
No.
I can't decide. Maybe I'm wrong. Dang. I tried to take a guess and I was wrong again. What the heck? Did you guys notice that somehow you suddenly can't chat right now?
Yeah.
Anybody notice that?
Yes. Yes, I did.
I'm telling you, Mr. Reed is darn rude. That's what happens. We get Mr. Blake teaching, and Mr. Reed starts figuring out ways to be really mean. Here you go. I'm turning it back on.
Now y'all know not to spam in the chat.
No doubt. I'll share that little trick with Mr. Blake. He can turn us off in the future as necessary. I like that.
I understand how you feel, but you don't have to spam it.
Want to switch my cohort group because I'm in B and nobody's in B. Literally nobody is in B.
Same.
Nope.
I am. Mr. Blake
I don't want to
is.
be in B. I do not care.
I am. I want to be.
Well, maybe.
Yay! Funstock will be there.
I guess I'll be in B for the first week and then I might switch to A. I mean, I don't know. But I don't want to be A. Nobody's in there. The only fun person in there is going to be me anyway. Sitting at a table
Well,
with myself.
you're gonna come in and cheer us all up. All right. I see all kinds of good stuff. So Mr. Reed has had just about every reaction up there. Probably the number 2 early on, but I kind of started learning a little earlier before they finally said, yep, we're coming back, that it was likely going to happen. I was like, maybe not, but but then there's all the excitement of, sheesh, we finally get to see each other. And then there's all the worry of, oh my gosh, how are we going to learn together while we're separate? This is just crazy.
Why uniform? We're going to be in there for literally 2 days. Why uniform?
We just want normal, casual, everyday clothes, just no uniform, please.
I can literally wear sweatpants and a hoodie and I will be satisfied.
Sorry, I hear all of you, but that's just part of the Mifflin way. So, or a couple other things. Well, one, we'll certainly, we know that for anybody that's brand new to Mifflin, because it's their freshman year, it's going to take some adjustment. And so we'll certainly be very considerate. That adjustment typically takes multiple weeks just because it takes that long to totally get to know the place. And now you're only going to be in the building 2 days a week. That's going to take even longer to finally get to that point of calling it home.
Even though I am a freshman, I will not be new to this building. I've been in it.
Cool. Yeah, I know some people definitely will, even if they haven't been in it as a student at Mifflin High School.
I'm also about to be in it for tennis.
Nice. We're also still going to be using our Chromebooks like crazy. We'll still, it's going to be an interesting transition and an interesting combo. And yeah, anyway. All right, enough about that. But, if there are concerns and questions, please don't hesitate to put them out there for us. And I'm going to go to a meeting today about planning how in the world we're going to make this the best, smoothest, easiest transition we can for everybody involved. So we'll see how that all rolls. I know you want to.
I don't want to be a B. I mean, I might change my mind, but I don't know. Because there's nobody there that I really know. I mean,
well, you just don't know yet, my man. There may be all kinds of people. Or if there's anybody there that you know, it's because you're supposed to meet some new people.
I'm going to call somebody that's in the A group during class.
Not. All right. So don't you worry. Just like you're like, what the heck's going to happen? So is Mr. Reed. I'm thinking about it. But time will help us get there. Let's see here. Where am I going next? We are going, well, I might stuff this guy back up real quick. The 3 points that we're trying to walk away from Desmos with. There's lots of things that we can get out of this Desmos activity, but the 3 things that we might be able to discover with regard to what a linear equation looks like and what changes we can make to that equation to change the graph, how it is that we translate the lines up and down the y-axis would be one of them, how we change a line from increasing to decreasing, and how we change the steepness of the line. So I'm going to run through a significant portion of our Desmos activity here so that you guys can hopefully see those different points. They're in there, but they aren't stated really clearly for you. So there, if you aren't already in this Desmos activity today, there's the link. Please join us, because as we talk through it, you're going to be able to make any corrections or additions or subtractions to what you've already done. So here we go. I think, oh yeah, this is how we do that. I'm going to bring everybody to slide 4 here and take a look at it. So the table's already showing what we would have figured out on previous slides, that each of these stars is at the same X and Y value. This is at the X value of 1, but it's also at the y value of 1. So this star right here, and this star has an x value of 2 and a y value of 2. And so here in the instructions, they're saying, well, check it out, x and y are the same. So that means that our equation could just say y equals x, and voila, all those stars are on it. Okay, so this y equals x line, the red line that you see there now, it is what we would call the parent graph of the linear function, because any line that you create is this equation modified somehow. All right, it's kind of nice to notice that it cuts the coordinate plane in half. It actually goes right through the middle of quadrant 1 and right through the middle of quadrant 2, chopping the whole coordinate plane in half. Yeah, so that's our friend y equals x. Then we're going to jump over here to number 6. And this is the first one where we actually are going to move that y equals x line up the y-axis. If you fill in this table, you can see the relationship between x and y more easily. When x is 1, the y value of this star is 4. And so that makes me think maybe I can do +3, and then I can check it out. Do I get 2 + 3 working over here? 2 + 3 is 5, and yes, that's the y value of that star. So it looks like +3 is the answer. But what I want to share with you is this neat little trick. If you want to move your line up or down the y-axis, all you have to do is look at the number you want it to cross the y-axis at and put that after the x. So this number right here is a +3. So after the x, I'm going to type in +3. And the line is right where I want it. So you can base that on the rule, the reality that you're going to take every x value and add 3 to it to get the right y value, or you can take the shortcut and look at where it's crossing the y-axis, and then you know exactly what to do. So if I want a line that's crossing the y-axis at 6, that's really easy. I just put +6. If I want one that's crossing the y-axis at 0, of course, y equals x does cross the y-axis at 0. Crosses through the origin, but you could also put in x + 0. Hey there, Aiden. Thanks so much, man. So if we move to the next one. Yeah. Then on this one, we're moving it down the y-axis. It needs to cross at -5. So I'm just going to write in there -5, and it's in the right place. If I wanted to cross at -2, then instead of -5, I would have typed in -2. Okay, so very easy thing to do, and it's something that's so wonderful about Desmos. When I was in school, if I wanted to check that kind of thing out, I would have been making tables of values on a piece of paper, graphing all those points, and then drawing the line. It would have taken forever, but look what technology makes it so easy for us to do. I'm saying that in large part because I want you guys to take advantage of the technology that's in front of you. You can experiment all you want and make new observations like this. Moving right along. Before I move along, does anybody have questions about making that line move up and down the y-axis? All righty. Then the next one is, this is where we're now hopefully figuring out if I want it to go through these blue dots, I just need to realize it's crossing the y-axis at -2. So to move this line down here, -2 after the x will do the job. Then when it asks you to explain why you chose that one, there's multiple ways to explain that. You can talk about, well, what I had to do to the x value to get the y value was subtract 2. Or you can say, well, I know that if it crosses the y-axis at -2, then I'll have a -2 after the x. However you want to explain that is fine. It's not just one explanation for it. So here on slide number 9 is where we look at the parent function y equals x is this red line, and it's increasing. But you see these stars, they're going the opposite way. As I read them like a book going from left to right, they're going down. So the stars are a decreasing situation. That's what we need to make this line. If we look at the coordinates, we can see that when x is -1, y is 1. When x is -2, y is +2. So all of the ordered pairs have opposite signs between x and y. If x is positive, then y is negative. So they tell us here, well, the way you make that happen is put a negative sign in front of your x. The way I often read that equation is not just y equals -x, but y equals the opposite of x. So if it's the opposite of x, then when I am talking about value of -2, the opposite of -2 means y is +2. Okay, so all it takes to switch a line from increasing to decreasing is a negative sign in front of the x. On the next one, now we need to switch this line from being increasing to decreasing, and we know to do that with our negative sign in front of the x. And then we need to move this line down the y-axis to get to where those stars are. We see it's going to cross at -4. So after the x, I can just type in a subtract 4 or a -4, and lo and behold, we have our line in the right place. Of course, the way you prove to yourself that it's in the right place each time is you launch it, and you need to see the word success there. Then we have this card sort. And I'm not going to spend lots of time on it right now. Unless you guys have questions, I'll be glad to address your questions. But I'm going to cheat and do the easiest one. The goal here is to make sure we have one equation, one graph, and one table of values connected for each group. And so this is y equals x, which means all the y values and x values are the same. That's close, but they're actually opposites there. Where is it? Oh, here it is. So then you just make sure you hover over the other card so it highlights and drop the one that goes with it. And now I've got a bunch of ordered pairs, so I could be looking for ordered pairs. But I'm dreaming that after what we've been saying about y equals x, that maybe you can just recognize it now. It has to go through the origin, and it's going to be at 1, 1, 2, 2, etc. It goes right through the diagonal. So bam, now I've got this group all taken care of. Get that out of the way. And then I just got to make a group for this equation, a group for this equation, and a group for this equation, and I'll be done. Any questions, guys? All right, if not, we've covered two things, going up and down the y-axis and how you flip a line from being an increasing situation to a decreasing situation. Now we're going to look at this idea. We have a line here, y equals x, the parent function, but the stars are at a different angle. They're steeper. And so if I filled in this table of values, it'd probably be pretty easy to see. But if I just look at the x value of 1 and realize the star's at +2 for y, and when x is 2, the star's way up at +4, 3, I'm way up at 6, you might be able to realize that I'm multiplying each of those by 2. I think that we're going to turn the chat off if that's what your concern is right now while we're looking at Desmos. That's what I think. Anyway, so 2 times 1 will give me 2. 2 times 2 will give me the 4. 2 times 3 will give me that 6. So if I'm multiplying x by 2, voila, 2 times x changed the slant of my line. It made it steeper. If we look even closer, every time the x value changes by 1, the y value changes by 2. That's because we're multiplying our x value by 2. Every time the x value changes by 1, the y value is changing by 2. So I wonder if I make this a 3, will the y value change by 3? Change x by 1, and now I'm not looking at the stars, but the line. I go up 1, 2, 3 to get back on my line. If I go over by 1, I go up 1, 2, 3 to get back on my line. That's the steepness, also known as the slope of our line. So if I change that to a 4, now every time x changes by 1, y is going to change by 4. Okay, so I'll put this back to the correct answer, y equals 2x. And then I could launch my marble to show that, yep, it really does work. So based on what we just said, yeah, I can drag this line into place, but what I need to figure out is every time x changes by 1, how much does y change? Or what do I have to multiply this 1 by in order to get this 3? Or I have to multiply the x value of 2 by in order to get a y value of 6. So whichever way you look at it, you're going to get an answer of y equals 3 times x. Okay, so that guy right there would be our correct answer. I think that's probably where Mr. Reed's going to stop. Does anybody have questions about that or anything in Desmos that I didn't just look at with you? Anas, I see the nope, it's 2x. I'm guessing that was the previous screen, but not hoping it's not the current screen that we last did. Alrighty, but let me know if there's questions or anything else we need clarification on. All right, we're really close to done. The only other thing I wanted to do, so if your Desmos activity isn't completely done, it needs to get there, should be there, but if it wasn't, I hope that that discussion helped you see some things that will make it easier finishing it off. And I want to take a look at the two types of problems that are in today's Desmos stuff. The first one, I'm guessing you guys are going to be like, Mr. Reed, if you give us another one of those, I'm going to barf, because all we're doing is the same thing that we have been doing for quite some time. We're plugging in the x value to find out the related y value. So this -2 goes in place of the x. I'm doing -5 times -2 plus 3. Sure, we'll write it out real quick. I'm just writing the equation here, even with the x and y. But then when I go to do this, I'm putting in y equals -5. Replace that x with that -2. And this is what we've been doing on Desmos graphing calculator plenty of times. Just type it in there, -5 parentheses -2 plus 3, and get the right answer. Then you don't have any arithmetic mistakes to worry about. But this would have been a 10 plus 3. What I'd be typing in right here is +13. Any questions? I can go back to that if we need to. And here's the other one. This one also is not hard once you understand what it's asking. It says writing a function rule giving a table of ordered pairs. These rules are just going to be a single step. So you're just going to add a number, or you're going to subtract a number, multiply or divide. And it's going to be the same number for every one, because if this is a function, it'll be consistent. So the question is, what do I do to this value of 1 to create an output of 4? And the first thing that comes to my mind is +3. But then I have to see, does that rule work for the next ordered pair, the 2, 8? Well, 2 plus 3 would have been 5, not 8. I can rule out that +3 right away. So I'm going to go back and think again. Well, I'm not going to subtract something to go up to 4. So maybe multiply by 4. And 1 times 4 is 4. 2 times 4 is 8. So far it's working. Will 7 times 4 get me to that 28? Yes, it sure will. So if I think about it, I took the input of 1, multiplied it by 4, and got this answer. Here I took the input of 2 and multiplied it by 4 to get the 8. Took the input of 7, multiplied it by 4 to get 28. So my input's now a letter, but it doesn't matter, guys. We're going to do the exact same thing. My input is not a 1, 2, or a 7. It's the letter N. But I'm going to do that same thing of times 4. That's my rule. Whatever input I have, I just multiply it by 4. It would be fine to type it in that way. You can also do this. They won't all be multiplication like that. As I said, sometimes it'll be plus, sometimes it'll be minus. So you just got to look at what's given to you and figure out what you can do that we'll always get the right answer. Any questions out there? It's up to you what you do with these last 7 minutes. Whether you work on Desmos, work on ALEKS. If you're done with both of them, I mean truly done, then I don't have any problem with you leaving, but only if you are done. Here comes some breakout rooms. Anas, I can come look at that with you in just a second here as soon as I create our breakout rooms. Oh, that wasn't Anas, that was Anusha. It wasn't Anas, it was Anusha. I'm going to go talk to Anusha real quick. I'll be back.
Okay.
Put me back in the main room. Oh, crud. I just signed my Chromebook out. Oh, well. Too much for Grant.